In this section, we are going to study parametric equations, which is just another method for describing curves. And we can think of a curve as the path of a point moving in the plane. And in this, we're thinking about the x and y coordinates as functions of time. So where would this object be located per time? And you'd have to think about where they're located horizontally and vertically as time changes. So this first one, we have a representative for x, and it's with respect to time, and y with respect to time. So usually we are given like some specifications for our time. So let's say we're going between 0 and 6. So that would mean I'd set my table up to go between 0 and 6. So what I do is plug that t in to find the x values at each time. So it's t minus 3, so I'm just subtracting 3 from each of those times. Then for y, I need to do 2 times the time minus 1. So 2 times 0 minus 1, 2 times 1 minus 1, 2 times 2, 5. So we start to notice a little pattern here. And then we can plot those points. So the first point, and there's nothing before it because we're starting with time 0, is at -3, -1. Then -2, 1. And then -1, 3, 0, 5, 1, 7, 2, 9, and 3 goes to 11. And that's all we're graphing because we are restricted on our time. That's all we're looking at. All right, let's do the same one, same time scale, so 0 to 6, and you will be specified what times to put in your table. For this one, it's t squared minus 3t, so 0. 1 minus 3, that'd be -2. 4 minus 6. 9 minus 9, that'd be 0. 16 minus 12. 25 minus 15. And then 36 minus 18. For the y values, it's t minus 1. Okay, so let's see what we get. When x is 0, y is -1. When x is -2, y is 0. Oh, wait, we have another -2? 1. Interesting. 0, 2. And then when x is 4, I'm at 3. When x is 10, I'm at 4. And then it's going off my page. So I'm kind of interested in what's happening right there. So I'm going to grab a calculator, and I want to show you something interesting. So if I go to the grapher, and I delete out, and I go into the templates, there is a template that says parametric equations. Now, it's set up kind of interesting. It's a parentheses with something kind of something, cosine, comma, sine, x, comma, y. So what I'm going to do is I'm going to change the x instead of cosine. That's going to be, and notice as soon as I hit my variable button, it changed it to a t because it knows that a parametric is with respect to time. And then the y value is going to be t minus 1. So what it's doing is it's plugging in different times into this to get the graph. And so when I plot the graph here, and I'm going to go up to auto, I notice that it is kind of curved. This is kind of a sideways parabola. And it actually keeps going off the graph because we kept going. It's like at 18, so it's way over here. Now let's look at what else can happen here. So what if we wanted to change this into a regular rectangular equation? So what we're going to do is try to eliminate t in both of them. So the first step here is going to be to solve for t in one of the equations. So I think the first one is going to be the easiest. So I'm going to take x equals t minus 3 and solve for t. So I would add the 3 over, and I get x plus 3 equals t. Since that is a representation for t, I can use substitution into the other equation and plug it in. So I get y equals 2 times x plus 3 minus 1. So y equals 2x plus 6 minus 1. Y equals 2x plus 5. Let's go look back at that first graph and see if it matches. Does that match 2x plus 5? Well, my y-intercept was at 5 and the slope was 2. It does. So it's just a different way to represent it. Let's look at this next one. So I'm going to solve for t. So step 1, solve for t. So I'm going to take, I think the second one would be the easiest. So that'd be y plus 1 equals t. And I want to substitute into this other equation. So this is going to go in where the t's are. In this case, I have 2 different t's. So I'm going to replace each t with that representation. Now, I could simplify this, and if it was on multiple choice, it probably would be simplified. So let's remember this is y plus 1 times y plus 1. So if I distributed that, I'd get y squared plus y, so 2y plus 1. Then distribute the negative 3. I would get y squared minus y minus 2. This is a parabola, but instead of x squared, it's y squared. So that explains why it's kind of sideways. Now, I also wanted to add in an example that wasn't originally on the notes. Make this example C. What if I was given x equals 2 cosine, well, let's just say, instead of t, what if they used theta? So my parameter is a theta. So my x is changing with that angle, and my y, let me make that a 3, is changing with some angle. And that can happen. It could be a t, it could be an angle, whatever it is. What I would do in this case is, let's get cosine by itself. And let's get sine by itself. Now, there's a reason I would like to do that. And that's because I know that sine squared plus cosine squared is always going to be 1, no matter what. So if I put y over 3 squared plus x over 2 squared, I now have a rectangular that is only involved with x's and y's. This would be y squared over 9 plus x squared over 4 equals 1. I have a beautiful new equation. I also wanted to talk about one more thing, so I'm going to kind of skip this application problem, and because that was pretty easy, you just plug in values. But what if I was given y equals 3x minus 2, and then I was told that t equals x over 3, and I was asked to create a set of parametrics? Well, I'm kind of going in the opposite way. This just has x's and y's, and now I want one equation that's x equals and one equation that's y equals. So the nice thing is I'm always going to have one that's easy to make. I can solve for x really easy. X equals 3t. Boom, I've got one of them. If I substitute back into this and replace the x with what x equals, I now have an equation for y. I have my set of parametrics. Let's do one more. What would you do first? Well, this time we're solving for x and we're solving for y. So I'd solve this for x. Boom, one equation done. We want the other equation to be with respect to t as well. So I'm going to replace x with t. Done.